Hi, and welcome back. We've seen some excellent sessions today. And together with Barbara, I'm going to host the last couple of sessions. We're here till, I think, 10:15, maybe some time after it because we're running a bit late, but that will be okay, I think. I'm very excited to be here. I'm Roland. I've been a developer for about 20 years. I'm very passionate about cloud, and I'm very excited to host these sessions with you with Barbara.
Yes. Hi. My name is Barbara Forbes, and I'm an IT consultant and a Microsoft Azure MVP. And I'm very excited as well.
Great.
There's some great sessions coming up.
Yeah, and I'm really looking forward to the next session because I'm a developer, and the next one is about Dapper, a distributed application runtime, from some amazing speakers. It's actually the one only session with 2 speakers today, so let's try if that works as well. You can post your questions in the chat. We still have the skills challenge, so the link is down below. So definitely check that one out. And are Edwin and Sander in the call already?
Yes, we are.
Hi, welcome.
Thank you so much for having us.
Most definitely, yeah. Thanks.
It's so great you could be here. And I always have a knack for ruining people's intro slides, so I'm trying not to do that this time. But you're both principal architect, you both work at Info Support, and you're both Microsoft MVP. How can we tell you apart?
Well, I'm an Azure MVP, and I'm not sure whatever kind of MVP Edwin is, but
I'm just developer technologies, but you know, I also do a lot of Azure, but I'm not the Azure MVP. That's so much. So yeah, there's a little distinction between us.
So that's what we can't tell which MVP you are, right? So, well, you have to see tonight, I think, for your session. So if you're ready, just take it away.
Yes, I shall share my screen. Let me see, and please let me know if you can see that.
Yep.
Yes.
Screen up. Pretty cool. Okay, so yeah, we're going to talk about Dapper today, and we're also going to look a little bit at eShop on Dapper, which is a reference implementation. And that's basically the eShop on containers that you might know. That's a Microsoft reference application, and we've basically ported that to Dapper, and we're going to use that as we talk about a couple of examples that we're going to show today. So without further ado, let's first look at what is Dapper. Well, Dapper stands for Distributed Application Runtime. And that's exactly what it is. It's a runtime that you can use as a developer to build distributed applications. And that's a very broad concept, of course. And what we see when we see people building these kinds of cloud-native distributed applications or microservices applications, we often see a lot of infrastructure being used. So you have message brokers for pops-up messaging. You have, state stores. You have maybe some discovery servers for finding services, all these kinds of infrastructural components. And this is exactly what Dapper can help you with, because basically Dapper is there to hide all these complexities of all these infrastructural components, so you can focus on building your application and not focus on all the infrastructure goo, so to speak, that you have to maintain. So that's where Dapper comes in. So let's look at how Dapper does that. So the Dapper runtime offers a quite extensive set of building blocks. And here you see a couple of them. And most of them we're going to look into a little bit more detail later on in the session, but I will walk through them quite briefly now. First of all, you have service-to-service invocation or service invocation. And this is basically for calling other services in your microservices application without knowing where they live. That's basically what it's all about. Then there's state management, and this is for storing some key value pairs or some contextual information in an outside store, so you can basically build stateful services, so you can rehydrate this state when you later on need it. Then there's a publish and subscribe building block. This is for pops up asynchronous messaging, quite well known, I think. And there's also some resource bindings and triggers. And these resource bindings and triggers can be used to integrate with all kinds of different external systems. And we will also go a little bit into more detail later on. Next to that, there's also a virtual actor model that Dapper offers. So you can build also actor model-based applications. And Dapper offers you built-in observability, which is very cool. So you can see what goes on within your system and you can monitor your services. Finally, there's also a secrets building block, and this is for handling, stuff that you don't want to publish, things like passwords or connection strings or certificates. And there's a whole suite of tools around that, and Dapper can abstract that for you. And then there's the last block. It says extensible, because the whole Dapper ecosystem is basically completely open source. And we think that more building blocks will come as time progresses. So that we will see multiple building blocks be added in the future. Well, the cool thing about Dapper is that all these building blocks can be called using standard HTTP or gRPC communication. So that also means that you can leverage Dapper from basically any platform or language in which you can do HTTP or gRPC communication, which is probably from everywhere. Of course, there's also a more convenient way of working with Dapper, because there are several SDKs available for different languages. So there's one for Go, for Java, for .NET, for Node.js. And this offers a more intuitive way for you as a developer to use these building blocks instead of through the raw HTTP or gRPC API. And then there are a couple of other frameworks that Dapper also nicely integrates with. For instance, ASP.NET Core, or Azure Functions, or Azure Logic Apps. Well, there's a lot to tell about Dapper. That's all not in this presentation. So we're going to focus on a couple of the building blocks and tell how these work. And then finally, what's also very important is that you can basically anywhere. So you can run it on your own laptop or your desktop when you're developing, but you can also run it in the cloud, in Azure, in AWS, well, basically anywhere on a cloud or edge infrastructure. So that's pretty cool. So how does Dapper do that? Well, Dapper leverages a sidecar architecture, and this is a well-known pattern because the Dapper building blocks are offered by a sidecar that's basically running alongside your application code. So in this case, there's several ways of running Dapper. In this case, we're running in a standalone mode. You just have your application code in a separate, OS process, and then the Dapper sidecar is run alongside that. And your application communicates with the Dapper sidecar to leverage all the building blocks. Pretty straightforward. Another way of running Dapper is in a Kubernetes cluster. And then the Dapper sidecar is basically deployed as a separate container within the pod of your application code, and it runs alongside your application. And because in a pod these containers can talk to each other, it is very easy for them to talk to each other and communicate between each other. So that is how this works when you run in Kubernetes. Like I said, we have used Dapper in eShop on Dapper, and Sander is now going to tell us all about how we did this to port eShop on containers and work with Dapper. So Sander, maybe you can share your screen.
Yes, I will share my screen. I just got a note from the production that my video isn't showing. I hope that at least my window is showing, because that's actually the important part. So
I can see it, but I don't know if it's in the live stream.
Okay, well, if you can see my window, I will assume it's also in the live stream.
Yep.
So yeah, we are going to look in the remainder of this session into some of the details of these building blocks, see how they work, how they can improve an existing application. And as Edwin already told you at the beginning of the session, for that existing application, we are using eShop on containers. So eShop on containers is a sample .NET Core reference application created by Microsoft, and it's basically implementation of a web shop that lets you buy some cool .NET merchandise, and now also some cool Dapper merchandise. And it uses a simplified microservices architecture with Docker containers. So let's have a look at the architecture. So we've got a front end here, which consists of a single page application, which is written in Angular. And backend requests from that front end are handled by an API gateway. And this gateway is implemented using Envoy, which is an open source edge and service proxy. And Envoy will forward the requests to a number of backend services. And there are many different backend services in eShop, and they are the services that really provide the core functionality, such as the catalog of items, the tracking of the items in your baskets, the entire ordering process, etc. Now, most of the calls from the eShop frontend can be directly routed to a single backend service by the API gateway. However, there are some scenarios which require multiple backend services to work together to complete a more complex request from the frontend. And in these cases, eShop uses an aggregator service, which is called a web shopping aggregator, to mediate that work across those different services. And then finally, backend services can also communicate with each other, and that is done using messaging to keep them nicely independent and loosely coupled. So this is the original eShop on container solution. And then we started to add Dapper to it. Now for the Dapperized version of eShop, each service now has a Dapper sidecar. And that makes it possible to use all those nice Dapper building blocks. And what you can see here is that we not only added a sidecar to each .NET service, but we also added a sidecar to the Envoy API gateway. And that enables us to use the Dapper service invocation building block to call the backend services from the Envoy proxy so that everything is Dapperized. So now let's look at some of those building blocks in more detail and see how we've actually applied them to eShop. And we will start with service invocation. So service invocation enables services to communicate with each other using either HTTP REST or gRPC protocols. And I'll also talk a little bit about observability because that's one of the benefits that you get from using the service invocation building block. So I've shown you the overall architecture of the eShop solution, but let's zoom in a bit and look at an interaction between the web shopping aggregator service and the basket API. So in the original solution, when a user adds or changes an item in the basket, the aggregator service calls the basket API to store the updated basket. And this is a direct service call to that service. So now let's see how we change this to work with Dapper service invocation. So first of all, if you use Dapper, Dapper takes care of service discovery for you. So instead of calling the endpoint of the basket API directly, you now make a call to your Dapper sidecar. And here's an example of making such a call using HTTP REST, but you could also use gRPC to communicate with a sidecar. So that URL they see right there, it contains the application ID of the service to call, which is basket API, as well as the method to invoke, which is API v1 basket. Now, using the application ID, the Dapper sidecar does all the service discovery for you and then forwards the request to the sidecar of the basket API service. And that sidecar, in turn, will make the final request on the actual service. And then the response will flow back the same way. Now, because these calls now flow through sidecars, Dapper can inject some very useful cross-cutting behaviors. So, for example, Dapper can automatically retry calls when they fail, when there are transient failures involved. Dapper can also make calls between services more secure using MTLS authentication, and it also includes automatic certificate rollover. You can add access control policies to control exactly what operations clients can do on services. And Dapper can automatically capture traces and metrics for all those calls between services to provide you with some insights and diagnostics. So I think it's time to look at some code. So let me switch over to Visual Studio. So as you can see here, I've got this complete solution opened up here in Visual Studio Code. This solution is completely open source. It's available on GitHub, so we'll share the link with you after the session so that you can play with it yourself. You can see here we've got some Docker Compose files. So I'm using Docker Compose here to run eShop locally, which is called self-hosted mode in Dapper terms. But we also added some scripts to the repository to run in Kubernetes. And Kubernetes is actually the preferred way to run Dapperized applications in production. So if I go over to the container step right here, you see a lot of containers are running. So my application already up and running. So I should be able to go to my web browser and show you the shopping front end. So welcome to our store. We've got some great products in here. As you can see, we just received some new Dapper swag. So for example, let's say I want to buy this nice cap, and let's throw in a Dapper hoodie as well. And if I scroll back to the top, you can see my basket here, which now has 2 items in it. And if I click on that, you can see the items. Maybe I want to buy even some more caps, buy some for my friends. And then you can check out the basket. All fairly basic web shop stuff. You enter your shipping address, you enter a payment method, and then you can place your order. And then you will see this pop-up notification because now there's an ordering process that has been started, and you will be kept up to date on the progress of that through Signal or notifications. So that is basically the whole eShop functionality in a nutshell. Now let's go back to the code. So in the previous slide, I talked about an aggregator service making a call to the basket API to save the updated basket. And if we look at the code of the aggregator, so the aggregator code is here in this aggregators web shopping HTTP aggregator folder. And here we find this basket service class, which is responsible for communicating with that basket API. Now, this call uses Dapr service invocation, and because eShop on containers is completely written in C#, we really wanted to use the Dapr.net SDK to make that call to have a more natural .NET experience. So using the SDK, we get this nice Dapr client object, which is injected into our constructor. And we can use that Dapr client to basically call all the different Dapr APIs on the sidecar. Now for this specific call, all the magic happens here in this update async method. So this will get the updated basket. And here we use the Dapr client invoke method async method to make the call to the basket API and give it that current basket. And that method takes a couple of parameters. So first I need to give it the logical name, the application ID of the service I want to call, which is stored in this constant here. So the actual value is basket API. I give it the name of the method or route, if you will, to call. I give it the payload to send, which is the updated basket. And lastly, because the basket API is protected, I need to send along an authorization header containing an access token. So note here how we use this HTTP extension object to pass along that HTTP header. And you can also use this object to specify other HTTP details whenever you are calling a service that has an HTTP REST endpoint. So things like query string or the HTTP verb, which is post by default, by the way, so I don't need to specify it here for this post call. Now let's have a quick look at the other side of notation, because this is the caller side and we're calling the basket API. So let's see what that looks like. So let's go to services basket. And there's actually not much to tell you because this is just a plain old ASP.NET controller. So this receiving end of the equation doesn't need to know anything about that, but it just gets called. So the call will go to this update basket, and that will take the updated basket and use this repository pattern to store it in the database. And we actually use the Dapr state management block for that as well, but I will show you that later on in the session. So now that eShop uses Dapr service invocation, one of the benefits is that Dapr will automatically collect those traces and methods I talked about. And we've configured Zipkin, or we configured Dapr to export all that telemetry data to Zipkin. So if I now go back to my browser and show you the Zipkin dashboard and run this query, you can see all kinds of tracing information for the stuff I just did in the eShop web frontend. So this is very nice. It's basically we are getting this for free just because we are using service invocation, and we get a lot of observability by that. And Zipkin also has this very nice dependencies page where you can get a very nice service map of all your services, because it can get that information from the traces, because yet again, everything is running through sidecars. And this is Zipkin, but there are other things you can use, such as Jaeger application, Insights, Prometheus. The Dapr team is currently adopting OpenTelemetry. So basically everything that works with OpenTelemetry, you can send your tracing information to. And with that, let's move to the next building block and look at some asynchronous messaging. So take it away, Edwin.
Yes. Let's look at publish and subscribe. If you look at eShop on containers, then all the services that are in there, we're communicating asynchronously using an event bus abstraction. And this event bus abstraction, there were 2 implementations for that created for eShop on containers, one for RabbitMQ and one for Azure Service Bus. And this is, of course, pretty handy because you could use RabbitMQ for your local development and test workload, and then use Azure Service Bus once you go to production, for instance. So you can switch between them. But because this is an abstraction, there were also 2 implementations, and there were several classes created for creating a connection to the message broker and also the behavior of the message broker, like sending and receiving messages. And this is quite an elaborate set of code that was created by the creators of the eShop on containers. Besides that being quite a lot of code, which is all infrastructural stuff that we basically don't want to be bothered with. We want to, build business code and add business value. Also, when using these building blocks, if you look in the startup class of one of the services, this is also quite an elaborate piece of code. So first of all, you have to figure out whether you're running with Azure Service Bus or RabbitMQ, and then also use the particular implementations of these 2 implementations. So it is, quite a bit of code, and there's also quite a lot of knowledge that you must have around these 2 message brokers in order to use them. And this is quite cumbersome. Well, this is exactly where the pub/sub building block from Dapr can help you. So let's look at how that works. First of all, what you can do is the Dapr sidecar, it offers an API for you to publish messages. So in this case, we are looking at the ordering API, which is one of the services within eShop on Dapr. And it can just call the Dapr sidecar using a well-known endpoint. And in this case, it's the publish endpoint. And there are several things that you can do. First of all, this is a post because you're sending a message and you need some sort of payload. And in this case, it's sent as a piece of JSON. So that's just basically the event or the message that you want to send. In the URL, you also see several things back. One is the component, and we will talk about components a little bit later, how you can configure this, because a component basically implements the building block. So in this case, we use a component that we call pub/sub, and that is the one that we want to use for sending this message. Now, next to this component, we also have to specify the topic that we want to send the message to. And a topic is basically like a mailbox that you can send messages to. And then other services can subscribe to these messages on a certain topic. So this is how I can send these messages. And when I call this API, and like we said before, you can do this using HTTP or gRPC or using one of the SDKs. And in eShop on Dapr, we use the .NET SDK. Once we have called this API, the Dapr sidecar will eventually call the actual service broker and deliver the message to the service broker. So this is why there are several choices here. So I could be using Redis, I could be using Nets or Azure Service Bus. Dapr abstracts that for me. On the subscribe side, there are also Dapr sidecars for the receiving end. And these Dapr sidecars will create subscriptions for the topics that you're interested in as an application. So let's here we see 2 sidecars. So we have 2 services. In this case, that's the catalog API and the payment API. They are both interested in these order status changed messages. So a subscription was created on this topic. And then once the message is sent to the message broker, the Dapr sidecar will pick up this message because it has a subscription on it, and it will call a certain endpoint on your application and deliver the payload. So this is how this works if you look on an API level. So how can you configure this? Well, if you're using .NET, and eShop on containers uses .NET, obviously, there's a really convenient way of doing some ASP.NET Core integration of Dapr. What you see here is the 2 web API methods. So these are 2 different controllers with a method on it, status change and status update. And these are just plain web API calls. And what I can do to make sure that I have a subscription on a certain topic and that this certain API is called when a message comes in on that topic, I can add a topic attribute to it. So this is something that comes from the .NET SDK, from the ASP.NET integration package. And you can just put the topic on top of it. And then you specify, again, which component you want to use, in this case, pub/sub, and what the name of the topic is that you want to subscribe to. And when you do this, the Dapr sidecar will pick up all these topics and will create subscriptions accordingly. So that's pretty easy to do. Also, there's some other stuff that you need to do in the startup of your application or your service. And there are also some convenience method to add Dapper to the application. In this case, you can call add Dapper on the services.add controllers that you already have there for your ASP.NET Core MVC pipeline. And this will add the services to dependency injection that are needed to use Dapper. Also in the configure method of the startup class, you see two calls. One is use cloud events. And this is because Dapper uses the cloud events format. This is a standardized format for sending messages. So when the message is received, it can be, unpacked and it can be read by the application and by the sidecar. And also the map subscribe handlers that you do in the endpoints part. This will make sure that all the subscriptions for all the topics that you have added will be created when the application starts. So this is all you need to do, and then you automatically start, reacting on messages that come into the certain topic that you have configured. So that's pretty easy. So how do you configure a component? In this case, a pub/sub component. Well, you create kind of like these resemble, Kubernetes manifest files. So you can create Dapper configuration files, and there are several parts in there. So first of all, you name the component. And as we saw in the sample before, the name was pub/sub, but this is something that you can provide. And you can also have multiple configurations, each with their own name. And this way you can switch between different configurations. There's also always a type in there. So in this case, it is a pub/sub building block, and the component it uses is Nets Streaming, which is one of the message brokers that is supported out of the box. And then finally, each type of message broker has some specific metadata that you can add to it. So this will differ per message broker. And by adding this configuration file and giving that to your Dapper sidecar, it knows how to interact with the pub/sub building block. So this is how that works. So let's quickly look at an example in eShop on Container. Just as Sander just showed the application, this is eShop. I already have some orders in here. Let me see, I have a message in Teams. Let me see what goes on here. Oh, that someone wants to get in, that's not for me. So what I can do now is look at all the topics that were created when the application was started. So what you see here are all kinds of topics, and these are in a Redis cache. So I'm using my Redis cache as my pub/sub component. And when the application starts and all these services start up, they will create certain topics that are used for sending messages. And as you can see now, there are no messages in these topics now. But when I, for instance, order a cool Dapper sticker and a Dapper cap, for instance, and I check this out, so I buy this, then what you just saw in the demo that Sander showed, in the background, some ordering process is being simulated. So there are all kinds of events flying around between the services. And if I now go back to the Redis commander and look inside the Redis and refresh this, then we can see that all kinds of events come in. So this is a user checkout accepted event or an order started integration event. And as you can see here on the right, these are just plain JSON files or JSON payloads that contain all kinds of IDs and stuff like that. And this is also according to the cloud events format. So that is how that works. So with that, let's go on to the next topic, and that is state management. So take it away, Sander.
Yes, I'm going to switch screens again. Be on mine now. So yeah, state management. So state management in Dapper provides a key value based API for persisting state. You can use it to create stateful services, and it's really meant to store some contextual data, not to store your entire relational database in it. So if you look at the original eShop on Container solution that uses a variety of data stores, many of the services use SQL Server, and they use Entity Framework to access the database. And that's perfectly fine because Entity Framework is very good for that. And the Entity Framework already provides support for many different databases, such as SQL Server, MySQL, Cosmos DB. So that already gives us a level of portability for relational data. Now, there are also some services in eShop that use other data stores. An example of that is the Basket API. So the Basket API stores its data in Redis. And to make that work, it has a dependency on stack exchange.redis, which is a third-party SDK, which you would need to learn to be able to use it. And we changed that implementation to actually use the Dapper state management building block. And as a result of that, we've now got many more different backing stores to choose from without having to learn any other SDKs. So let's see how this works. With Dapper state management, you can store and load the state in the key value store by simply, yet again, making calls to your sidecar. So if the basket API wants to update the basket, it could simply do a post request like this with the data it wants to store. And then the Dapper sidecar will persist that state to the configured backing state store, whether that's a Cosmos DB, a Redis cache, or some other store. And then to read that value back from the store, you can do a GET request. And in that request, you specify the key you want to query. The Dapper sidecar will look it up for you from the backing store and return it. So let's see what that looks like in code. Now, eShop already used this repository pattern to access the data store. So for example, if I go to the basket API, then in infrastructure repositories, we've got this Dapper basket repository. Now, of course, in the original solution, this wasn't called Dapper basket repository. It was called Redis basket repository. And we changed that name and that implementation to use the Dapper state management. And let's start at the top. So as you can see, we again use that Dapper client, we get it injected in the constructor, and that allows us access to all those nice state APIs. And as you can see here, those state APIs are pretty simple. So if we want to delete something, we can simply call delete state. We can retrieve state by calling cat state. Here we use cat state entry, which makes it possible to get something from the state store, change the value, and save that back to the store. So in this way, we can do an update. Now, the state store that actually does the persistence is configured in a component file. So let me go over to the component file. And as Edwin already showed you, that's just a YAML file, looks very similar to Kubernetes manifest files. And here you can see that we are currently storing our basket state in table storage. And this file also makes use of another Dapper building block, which is a secrets building block, because I don't really want to store my storage account key in this file, because this file will get sent up to GitHub in source control. So instead, I'm storing secrets in Azure Key Vault, and I'm telling Dapper using this secret key ref and this configured secret store to get that account key from Azure Key Vault. Now, let me quickly show you that this also actually works. So let me go back to the shop. You can see right now we just placed that order, so my basket is empty. So now if I go to Storage Explorer and I go to the storage account, my table should be empty because there's nothing in my basket, and I'm currently the only user of this instance of the application. So as you can see, there's no data in the backend store yet. Now let's add something. So let's say I want a .NET path black hoodie. Now we've got something in the basket. If I switch back to Storage Explorer and refresh, then now you can see if I click this open, look at the details just to prove it to you, you can see that there's now a .NET Path black hoodie in my backing store. So that's a very easy example just to show you how it really works, but realize that you can now very easily change or switch backend stores just by changing that configuration. You do have to be aware, though, of subtle differences between implementations. So for example, with table storage, a single value you can store in a table storage column has a maximum of 32,000 characters. So if you're switching between a store that has such a limit and a store that lets you basically store unlimited sizes of blobs, then maybe you run into some problems with your applications where one store cannot store all the data that you want. So you gain a lot of portability with this layer of abstraction, but you still need to pay a little bit of attention to the actual implementations. And then I do think we still have got some time to talk about bindings, Edwin.
Yes. So let me share my screen. Thanks. Resource bindings are basically a way to integrate with different external systems. And this is a very broad aspect, of course. And you could argue that also pops up, for instance, as a way of integrating with different external systems. But there's quite a small difference there, because this does not only focus on message brokers and sending events and doing asynchronous messaging, but it also has all kinds of bindings, for instance, for Twitter and Twilio SendGrid and Azure Storage. So it is basically a way of getting events from certain systems, for instance, when a file is dropped into an Azure Blob storage or whatever, and then get an event into your application. Or if you want to do something, you want to call you want to send an email or whatever, there's also a way of integrating then, for instance, with Twilio SendGrid to send this email without knowing how Twilio SendGrid works. So you do it through the Dapper building block, the resource binding. There are two types of bindings. There are input bindings, or they're also called triggers, and they react to events. And you have also external or output bindings that you can use to do outbound communication, like the Twilio SendGrid thing. Also, I have to stress that because these are just Dapper building blocks, you can use them through HTTP or gRPC for calling them, or to the SDK. So how does this work? Well, here I have an example of an input binding, and I'm going to use a Twitter example. So I have my service running, and I have my Dapper sidecar running, and this Dapper sidecar has a configuration file it interprets when it starts up. And in this case, it's a binding, an input binding for Twitter specifically. And as you can see in the configuration file, I give this thing a name, tweet, and this is very important. I will show you in a minute why that is. And also, you see the type, bindings.twitter, and you see some specific metadata. In this case, it's some credentials to connect to some Twitter feed. And there's also a query in there. That's one of the functionalities of the Twitter binding. You can specify a search term, and when a tweet is sent that has this term in the text, it will be picked up by the binding. So once Dapper has read this configuration file, it will connect to Twitter, and it will start looking for tweets with Dapper in the text. And once a tweet is detected, it will pick that up, and it will call your service on a certain endpoint. And here you see that the name is again really important, because this name is used as the endpoint that is being called on your application. So in this case, the service is running on port 5000, and you have to have an endpoint that listens to /tweet, and it will get the payload with all the information around of the tweet. And then you can handle that, whichever you want to do with this tweet, and then you can send back a 200 OK to tell Dapper that this message was handled successfully. So this is how you can use an input binding. The output binding is quite similar. So again, I have a service with a Dapper sidecar, and now I have configured an output binding. In this case, it's a Twilio SendGrid binding, and I call it send mail. And now what I can do from my application, and this is what we actually use in eShop when we start sending emails, for instance, when an order has been completed, from our service, we can call a binding endpoint, and we use the same name as we have used in the configuration for this output binding. We give it a payload, and then the Dapper sidecar will actually invoke SendGrid and send the payload over there, so the email will be sent. So this way, I only need to know the Dapper API, and I can send emails from my applications without knowing how SendGrid actually works. I only have to provide some API key or something in the metadata, so Dapper can connect to this service. So that's pretty cool. As I stressed before, Dapper is completely open source. So all these components, you can write them yourself. And you could also, of course, write bindings for all kinds of different systems that are not already out there. You have to do it in Go, because Dapper is built in Go, but there is a possibility for you to build your own bindings, input as well as output bindings for your system or some other service that you want to use from your application. So that's pretty cool. So, and with that, yes, of course, Dapper will send you a 200 OK when the message has been sent. With that, we are through the stuff that we wanted to show you. So thank you for listening. Thank you for having us. It was great being part of the Virtual Azure Community Day. There are some resources up here. There's some links to the documentation and to the eShop on Dapper project on GitHub. And if you want to see more of us, you can watch our .Netflix video channel. And I don't know if there are any questions in the chat. I think we have a little bit time for questions.
Well, I have a question myself. Can we expect to see this in the wild at the moment?
Well, we're still in. There is now a release candidate version, and we're working closely with the team. And I think that somewhere, first quarter next year, there will be a 1.0 release that is actually generally available.
So 2021, we can expect to see this out there.
Yeah.
So cool. Exactly. It was such a great, clear explanation of Dapper. Even I understand, so that's usually a good sign. Thank you so much for this amazing session.
Yeah, thanks for having us.
Yeah, it's great. Thanks.
Thank you.
Have a great rest of the conference, everyone.
Thank you.
Thank
Bye-bye.
you. Yeah, awesome. So